Welcome back. Let us code our second project for the web application penetration testing section. So, in the previous video, we took a look at how we can create a simple brute forcer that will be able to brute force both of our DVWA login pages. We made the post request, we also made the get request, and we also changed fields accordingly to each one of those pages. Now, as I already mentioned, that program you will need to adjust for every page that you brute force. However, this program that we're going to create right now, which is the directory brute forcer, you won't need to adjust for different pages, it will work for every page. And what a directory brute forcer is, as we already mentioned, it will discover some hidden directories that could possibly be useful to us once performing web application enumeration. So this is something similar as a DERB tool that we covered in web app penetration testing section. So let's get straight into it. I'm going to open the terminal and I'm going to navigate to our desktop and tools directory. Here we got our web app penetration testing directory, and right here inside of this we got our previous project. Let us now nano a program that we can call directories.py. As the previous program, this one is also going to import the requests library. And before we start coding it, let's first think how our program is going to look like. So we're going to ask the user of the program to specify the target URL or the target link. Then we will open a file that has common directory names. We will read from that file, and for each directory name, we're going to perform a request for that page. If we receive a response or if we manage to load that page, that means that directory exists on that page. If we get something like a connection error, that means that page doesn't exist. So this program is really simple. Let's start coding it. And first thing, as we said, is going to be the target URL. This is going to be equal to the input value as usual. And here we can specify something like this. And then enter target URL. What we also want to ask from the user is the file name. So file underscore name is going to be equal to input, enter name of the file containing directories. Okay, so these are the only two things that we need. After we get them, we can open our file like this. So file equals open, and then the first parameter is going to be the file name, which they specify, and the second parameter is going to be opening file for reading. And this is something we already covered, so you should be pretty familiar with how we open files. As soon as we open file, we can start reading different directory names and requesting those pages. So for line in our file, for each and every directory in our file, we're going to first strip that line from any additional characters, and we're going to store that inside of the directory variable. So directory will be equal line.strip. After that, we can create a full URL variable, and the full URL variable will be equal to target URL plus, and then slash, and then plus our directory. So what we are essentially doing right here is, let's say the target inputs a website link or a domain name of google.com. Let's say they input that, and from our file we read the admin directory. Essentially what we are doing right here in this line is we're combining these two like this. So this is how we search a directory on a certain domain. We simply just add a slash and type the directory name. Now that we got the full URL variable, we can perform the same thing from the previous video. Response will be equal to request from full URL. And this request function we don't have. It is not request.get or request.post. It is just the request function that we're going to code right now. So go up here and type define request. This request, of course, takes the parameter of URL. And what this function should do is it should try to connect to that page that we're looking for. And if it doesn't manage to connect, we're just going to pass. So how can we do this? Well, we can type try and then we can try to return from this function requests.get. And the reason why we are returning is because we're going to store the response inside of this response variable. So we're essentially returning requests.get, and then let's add HTTP / and plus our URL. So it is going to essentially try to visit our URL. We're just adding it the prefix of HTTP //. So like this, everything should work. If we manage to visit that page, we're going to return the value, and if we don't manage to visit that page, in case of requests.exceptions .connection error, we're just going to pass. And let's not forget to add 2 dots at the end of the accept statement. So in this case, we didn't manage to connect, therefore we're just passing, and the return value inside this response will be nothing, since we're not returning anything. So how can we then check which one managed to connect and which one didn't manage to connect? Well, we can just type the if response statement. And what this if response means is, if there is something in response, then do the following statement. If there is nothing in response, then it won't do anything. So in this case, if we have something in response, that means the try statement worked and we managed to connect to that page. So we're just going to print discovered directory at this path, and we're going to print the full URL. Simple as that. And this is our entire program. Let's go through it once again real fast. So we import the requests library. We ask the user of this program for the target URL. We also ask for the file name. Then we open that file and we read each and every line inside of that file. We strip it from any additional characters and store it inside of the directory variable. Then we create a full URL variable that will be the combination of target URL / and the directory name. Then we request that full URL, and if we manage to connect to, we will return this value inside of the response variable. If we don't manage to connect, this response variable will stay empty, and then at the end we're just checking if there is something in response, print that we discovered the directory at this path. If there is nothing inside of the response, it will not print anything. So let's test our program out. I will save this, and all we need to do is python3 directories.py. We enter the target URL, so let's just go and see what is the IP address of our Metasploitable, and in my case 192.168.1.2. And the name of file containing directories. So we need this file. And luckily, inside of our Kali Linux, if I open a second terminal and I type locate dirb or derb, however you want to pronounce it, we go to the user share and then derb directory, type ls, we will have this word lists directory right here. If we change to that directory, so cd word lists and type ls, we will have a bunch of these txt files. And inside of this common.txt file are common names for different directories. So what we can do is we can copy this common.txt file inside of our home, Mr. Hacker, then desktop, and then tools, and then web app penetration testing directory. Once I go to that directory and type ls, we should have our common.txt inside of the same directory as our directories.py file. So now if I go right here and specify common.txt, press enter, this will go and search for every directory, and we can already see that it is discovering some of them. We got the / directory, the /dev, /index, /php, /phpMyAdmin, and those are all the directories that it manages to find in the main directory of the Metasploitable machine. Now, you can also specify subdirectories if you want. For example, if I run the program again and type 192.168.1.2/dvwa, and I type the same file name, which is common.txt, now it will search for the directories inside of the /dvwa. and we can see it is finding different directories than it found right here. And what you would basically do once performing this type of enumeration is you would try to find something interesting. You would go from each and every subdirectory and try to figure out if there is any interesting directory onto that page that maybe shouldn't be there. For example, if I run our program and I type the IP address /mutil IDAE, which is the name of one of the directories on our Metasploitable, I press enter, and I also use the command.txt file. It will find a bunch of the directories, but there is a directory that particularly stands out, which is this passwords directory. So we can visit that link, which is 192.168.1.2, and then mutil day/passwords. And it will lead us to this directory, which has this accounts.txt file. If I click on it, well, it seems like we found some file that contains usernames and passwords. We got admin, the password is probably admin pass, and this could be something like a security question and the answer to the security question. So this would be a vulnerability of information disclosure where it gave us some information that we shouldn't have the access to. And we would never know that this passwords directory exists if we didn't run our directories program, which discovered it, and then we visited it and found out that there are accounts, usernames and passwords available for us to read. Okay, great. So we have finished 2 projects successfully. We coded the login brute forcer and the directory brute forcer. So we are officially done with web app penetration testing. And in the next section, we're ready to touch on a subject of man-in-the-middle attack. It is a really interesting attack that we can perform inside of a network, and in the next section we're going to see exactly how we can perform it. See you there.